Yes, hey, welcome back. And yeah, I was thinking of solving Sudoku Solver yesterday itself, and the thing is, I actually solved it and uploaded the video also. But there was something wrong with my recording equipment, and what happened is that what got uploaded was something which is purely blank. It had no content.
Yes,
Welcome back. And which made
and
me
today,
pretty sad, thinking that I had because I have to record the video again. But hey, that happens. Sometimes things will be in your hand, we check it properly, and things I did not properly, it was not in my hand. And yeah, so now directly let's go on to solve the problem. So what you have to do is let's have the basic things set up. Class, and yeah, there should be no parentheses. So there should be parentheses. And the only thing which you're setting up here is the board. So yeah, you'll have zero columns, range 9. I can actually make it as like this also. And you will have 9 rows. So for one more in 9, yeah, this is least comprehension. It is just like writing lambda expressions. And yeah, let's just print the board ones. So let's have a method called RINT. And yeah, now it's not written. Yes, perfection is essential. So let's have a class called Sudoku. I mean, let's instantiate the object of Sudoku. Yeah, and let's have one more thing. Yeah, rather than directly passing it through the constructor, what we'll do is we'll call a solve method, which will actually solve the Sudoku for us. So yeah, you have to have self over here because you're calling it from inside the class. It is solve Sudoku. Yeah, we are just calling it as solve, right? Yeah. So first of all, let's just print the board dot once. Print board, yeah. Is the board getting initialized properly? And yeah, it has 9 rows, 9 columns. And yeah, let me tell you the rules of Sudoku. So Sudoku, what happens is that you'll be given a 9 by 9 grid. What you have to do is you have to fill values in the grid such that the given value which you fill should not be present in the row, should not be present in the column, or should not be present in the 3 by 3 grid. So this is 3 by 3 one grid, 3 by 3 two grid, like here this much. This is one grid of 3 by 3, and this is two grid of 3 by 3. Well, from here to here, and again this is the final grid of 3 by 3. Yeah, it goes on like that, and the number should not be present in the row, column, or the grid. So yeah, again this is a pretty classic backtracking problem. So let's define the backtracking. It's not diff over here. Yeah, we are actually calling it. Well, let's define the backtracking over here. Yeah, and so from where you'll start, you'll actually start filling the value from 0 comma 0. So let's have 0 comma 0 over here. And yeah, what is the 0 comma 0? It's actually the current row and the current column. So so when you'll stop solving the Sudoku, first, yeah, let's get the first base case out. So whenever you reach this value, in other words, when the column becomes 9, you have to increment the row by 1. So you have to go over here, but your column will still be pointing here. So you have to reset the column to 0. So let's do that now. If column becomes equal to that, uh, increment, yeah, what is this? I. Yeah, let's keep it clean. So if column becomes equal to 9, then set column back to 0 and increment the row by 1. And if row becomes equal to 9, so in other words, you filled this part and you're going next, and you obviously don't want to go next because there is actually the end case. So what you do, directly return the bold itself, or else what you have to do for each value, for each grid path, grid, what do you tell, for each position, yeah, position is a good word. So for each position, for you have to fill the values from 0 to 9. So for I mean range 1 to 10, yeah, 10 because last index is non inclusive. So if If it is valid, uh, self, yeah, I will declare the value of is valid afterwards. If the given row column is valid and can be filled with the given number, so what you have to do, put the number in that row and column. So self dot board with the position row at the position column, put the number. And yeah, one more thing I forgot over here. And if the given position is already filled, so if it is not zero, then you have to continue the backtracking to the next part. So if board at the position row at the position column, if it is actually filled, so if it is not equal to zero, that means that continue to the next part. Backtracking, just keep the value of row constant and increment the column by one. And the handling of row is actually done over here, so there's no need for to worry about row. We'll just pass through everywhere, but we'll just increment the column by one. And don't forget to return it. And yeah, after checking if the position is valid, continue the backtracking. And if that backtracking also returns true, that means that you have actually found your solution. That means that first it will do this, it will do this, it will do this, and after it reaches this position, it will actually return the board. And then it will start to keep on returning the board. It will return board. And as soon as it reaches over here, that means that the entire thing will return true. So if it actually returns something, so return the board itself. Or else, if it did not return anything, that means that the given number could not be placed in the given row and column. So return reset the value of board at the position row column to be zero. Uh, so reset the board to yeah, I reset it back to zero. Yeah, believe it or not, this is the entire backtracking part. So only thing we have to do now is to define the is valid part. So we are getting it in the form of a row, column, and number. So again, this will have three parts. So we have to validate for the row, column, and the three cross reference. So yeah, if all the three returns true, that means that we have actually found the solution. Yeah, and let's do one thing. Let's directly copy it. Yeah, and then make this O. And let me paste it over here. Let's first make this as O. Yeah. What I'll do, I'll go to home. I'll cut this part out. I'll remove this part. I'll give some space. I'll call it as def, and I'll place the self over here, comma, and then I'll put this over here. Yes. So for is valid row, what you want? So you want to check if the given row is valid. So take the row and take the num and so yeah, you have to take the row and num. You will get the row and you will get the num. So yes, so now what you do? You have to keep the value of column constant and you keep on changing the value of row. That means that you will actually get column over here. You will actually get column and you will actually get column because you have to keep the value of column constant and keep on changing the value of row for row in range 9 and no pop-ups. Yeah, for row in range 9. Let me just check if it is recording properly. And yeah, it seems that it is recording properly. Yeah, that is actually one good thing. So for row in range 9, if don't forget actual for it. If it becomes equal to num, that means that the given number is actually present. That means that this number was actually present beforehand only. That means you have to return false over here. Or else, and then while checking for is valid column, you'll actually have to keep the value of row constant and you'll take the num. And yeah, let's finish the is valid column. So you'll get the value of row and you'll get the value of num. Yeah, row and num. So for call in range 9, again, the remaining part remains constant actually. Yeah, for valid frequency, what you have to do is you have to pre-process the data. Again, if you're over here, what you have to do, you have to actually reset the row and column to here because you have to check this three, and this three. And if you're over here, you have to reset it to this three. You have to reset it to this point because that's how you're actually checking the frequency grid. And there is a brute force way to do this, or there is a mathematical way to do it. And let's go with a mathematical approach. So what you have to do is you just take the, let's call it start row in the start column. And what you have to do is you have to take the row and divide it by 3 and multiply it by 3. That's all. But first do the division part and then do the multiplication and do the same for column also. Take the value of column and divide it by 3 and then multiply it by 3. And then what you have to do is, yeah, and then you pass the row and column over here. So, no, yeah, it start row, the start column, and the number if you want to check. And let's pass those over here also. Yeah, let's pass those over here also. And then what you have to do for row in, now you have to check for the 3 cross 3 grid. So for row in range 3 and for column in range 3. Now what you do is you are actually starting from here. From that you have to actually add the value of row also to get the proper offset. So if self dot bold at the position row plus start row at the position column plus start column, if it actually becomes equal to the number which you want to check, that means that the number can't be placed, so return false or else return true. I think that's all for it. So now what you have to do, let's just check it out once. And yeah, it looks to be solved. 1, 2, 3, 7, 8, 9. Yeah, let's do one thing. I have already opened a tab which will actually check if the given Sudoku is valid or not. Let's just fill these values over here. Can I do this? I can't. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have 1, 2, 3. And then you have 1, 2, 3. You have 4, 5, 6. You have 7, 8, 9. You have 4, 5, 6. And then you have 7, 8, 9. You have 2, 1, 4, 3, 6, 5. 9, 8, 9, 7. 5, 3, 1. 6, 4, 2. 9, 7, 8. 5, 3, 1. 6, 4, 2. Yeah, filling this is a chore, but you have to do it. 9, 7, 8. 2, 9, 7. It's not 2, 9, 7. It's actually 9, 7, 8. It's 9, 7. Okay. 9, 7, 8. 5, 3, 1. 6, 4, 2. Yeah. Again, it is 6, 4, and 2. 9, and it is 9, 7, and 8. 6, 4, 2, 9, 7, 8. 5, 3, 1. 5, 3, 1. Yeah. Let's fill it, or else I'll get more confused. 3, 6, 5. 8, 9, 7. 8, 9, 7. If you see, actually, it is repeating 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, 4, 5, 6, and so on. Yeah, 8, 9, 7. 8, 9, 7, 2, 1, 4. 2, 1, 4. It's 2, 1, 4. 3, 6, 5. And yeah, let's validate it. Yeah, that's what we wanted to see actually. The Sudoku is solved and there are no errors. Yeah, if you want, you can actually set the values of some positions also. You can do. at the position 0, at the position 0, let us, yeah, not comma. Let us set it to be equal to 8. Let's save it and run again. Yeah, and you see, now again you'll get a solid board of itself. But yeah, be careful. You can't like do like this. And if you actually give it an wrong board, it will take a lot of time and it'll. I don't think it will terminate. Let us just take it out once and wait for 30 seconds. Yeah, looking at this, I don't think it will solve. So you can actually do one more thing. You can have one more function called is the initial board valid, and in that you can actually check the initial board itself. And yeah, for you can actually modify this very little to check if the initial board itself is valid, and only if the initial board itself is valid, we can proceed with that, or else we'll just return board is not valid. Yeah, you can actually add that as a bonus also. Yeah, you just try it out. Let me not give the entire recipe. Be explorative and try it out. And yeah, that's all for it. Thank you for watching. See you next time. Bye bye.